this one. Yeah, so that's kind of the plan. So, and then I believe you're going to be turning in textbooks, seniors, next week sometime. So my hope is like nobody would need their, if you have a physical textbook, you don't need it after next week. Okay, so 14.2, the binomial distribution. We are now going to examine a special discrete random variable, which is applied to sampling with replacement. The probability distributions associated with this variable are known as the binomial probability distribution. The binomial experiment is when you have a repetition of a number of independent trials in which there are two possible results. We're going to call it success, that the event occurs, or failure, that the event does not occur. Then this is called a binomial experiment. The probability of a success, P, must be constant for all trials, and Q is the probability of a failure. So Q would be 1 minus P. The random variable capital X is the total number of successes in N trials. So in order to have a binomial distribution, the following 4 things must be met. There are 2 outcomes. We usually call success or failure. The number of trials is fixed, like there's 8, or there's 12, or there's 20. The probability of success is the same across all trials, and the trials are independent. The probability of success in one trial does not affect the success or failure of a previous trial. In general, in the case of N trials where there are R successes and N minus R failures, we're going to write it up here so you can see it a little better. The probability of X being that success, there's a formula. It's NCR times P to the R power times Q to the N minus R. Now I'm going to show you a different way to do this that you don't really have to do it this way, but this is technically where it's coming from. So let's look at example 1. It says studies show color blindness affects about 8% of men. A random sample of 10 men is taken. Is this a binomial distribution? Well, are there 2 outcomes? Yes, you either have color blindness or you don't. Check. The number of trials is fixed. Well, the number of trials is 10. There's 10 men. The probability of success is the same across all trials. The probability of having color blindness is 0.08. Then that makes Q what? 0.92. The trials are independent. So because if the first person is colorblind, that has no impact on whether the second person does or doesn't. Okay, it's fixed and it's independent. So yes. Now it says find the following probabilities that all 10 men are colorblind. Well, one way to do this is to use this formula. And we're actually not going to use it, but we're going to start with it. So do you happen to remember when we were doing like binomial theorem? And hey, that binomial theorem problem, I was like, you could do that one. We practiced that on that test. I was like, yes, hopefully you got it because we did that one multiple times. So 10 choose 10 is always 1, right? Like it's n choose n is 1. So, and then 0.92 to the 0 is 1. So on your calculator, all you're doing is 0.08 to the 10 power. And this ought to be teeny tiny. So I got 1.07 times 10 to the negative 11. Well, grab your graphing calculators if you have it. And I want to show you, because this is a pain to write out and to do, and you don't have to now that we have the technology. What you're going to do is you're going to press menu. And you're going to tap 5, followed by 5. And then you should scroll down. And you should see something called binomial PDF. So again, you open a blank document, press menu. 5 is, I think, probability. 5 is distribution. And then you scroll all the way down until you see binomial PDF. Yeah.
Blank document, you mean
Calculator. Yeah. Yeah. Just not a graph or a table. Yeah. Yeah. So you're going to click binomial PDF. And then what you do is you enter N, which is 10. The probability of the success is 0.08. And then this is, you want all 10 to be colorblind. And if you do that, you're going to get the same answer. So if I want that no men are colorblind, this would be the probability of X equals 0. So you're going to go back and do binomial PDF, because we're going to see in a moment that there's binomial PDF and binomial CDF. P stands for a particular value. C is continuous, where it's an interval. Okay, so this is going to be, I have 10 trials, 0.08, and now I want 0. I got 0.434. You getting that? For those of you with your calculators, good. All right, then if I want exactly 2 men to be colorblind, like, do you understand that in these first two, if they were all colorblind, it's the 0.08 times 0.08 times 0.08. And if none of them, that's the 0.92 times 0.92 times 0.92. The reason why we have to have the NCR is for part D. If exactly 2 men are colorblind, the order matters. Person 1 and person 2 is different from person 2, 3, and 3, 4, 1, 8, 1, 10, you know, like, so there's all those combinations. So here, if I want exactly 2, this is going to go 10, 0.08, 2, and I got 0.148. In part E, what is the probability that at least 2 men are colorblind? So now watch this, be careful, because the answer is not the same as part D. 2 and at least 2 are not the same. So this is an interval. So we would consider this to be a continuous interval. So you're going to go 10.02, and then it asks you for a lower bound and an upper bound. So this is going to go 2 to 10. So you're still going to go menu 5, 5, but then you arrow to binomial CDF. So CDF is an interval, PDF is a particular value. And I got 0.188. You guys get that? All right, nice, 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 nice. Okay, so now let's look at example 2. And I'm going to give you a moment to try these on your own. It says 72% of union members are in favor of a certain change to their conditions of employment. A random sample of 5 members is taken. Find the probability. Sorry, I don't know what happened to my letter A. 3 members are in favor of the change in conditions, and C, at least 3 members are in favor of the changed conditions. So try to figure out what you're going to do here. Then I'll work it out. Were you in the wrong mode?
No, it wasn't that.
Oh.
I was in ratings and it was a rating problem.
Uh-huh.
I graphed it and it was like jumpy like that. It wasn't even a function because it would go back on itself like that.
Whoa.
I had to like just stop the question because I couldn't go on past it.
Yeah, I have no idea what happened.
Huh.
Was it the velocity one?
Yeah, I think so.
Yeah, the one with the cosine. Yeah, that cosine function I could not graph.
Huh. Well, I'll have to pull it up and look at it now. Oh, that was I haven't looked at the calculator part, but when I get a chance, we definitely will. All right, so part B, I said this is the probability of X equals 3. So which one are you going to use? Binomial PDF or CDF? PDF. So what is N? How many trials are there? 5. So you're going to go 5 and it's 0.72 and I want 3 members. So I got 0.293. For C, I want the probability of at least 3 members. So I do want you to be able to like write out the probability statement. Okay, so I know what you know. Then this one is binomial CDF. So you have 5.72, then it's 3, 5. And I got 0.862. You guys got it? This is easy. This one's going to be like, okay, a relief. I thought 14.1 and 14.2 are easy enough. 14.3 is going to be a little bit more challenging, but not terrible, not terrible. We already know this one. We toss a coin 20 times. If the probability of getting ahead is 1/2, you would expect N times P, which would be 20 times 1/2. You'd expect ahead 10 times. In general, if a binomial experiment is repeated N times and a particular variable has a probability of P of occurring each time, then our expectation is that the mean, and this is the Greek letter mu, is N times P. The standard deviation, that's the lowercase sigma. Okay, standard deviation is sigma, and it would equal the square root of N times P times Q. So I'm going to do example 3, then give you a moment to do example 4. A fair die is rolled 12 times, so N is 12. And X is the number of 6s that could result. Find the mean and standard deviation. So P would be the probability of rolling a 6. So what would that be? 1/6. Well, what is Q? The probability of not getting a 6. 5/6. Okay, there we go. So then the mean, which is mu, it's like a funny looking U. It's got an extra little beginning part, is N times P. So you would expect to get a 6 twice. That's the theoretical, okay, the theoretical expectation. Then to get the standard deviation is sigma. That's the square root of N times P times Q. So this is 12 times 1/6 times 5/6. And remember, your mean is your average, and standard deviation is the measure of how spread out the numbers are. All right, go ahead and try example 4 on your own. So I got a mean of 4. So you would have a mean of 4 that are defective, 4 batteries. Then my standard deviation would be 80 times 0.05 times 0.95. And I got 1.949 or 1.95. Okay.